I hope you are starting with a good day. And today we're gonna learn in AI, ML, IoT the continuation of yesterday's topic, which is natural language processing, session 22. Yeah. So I'm gonna start the chat box also. So if you are, yeah, we have 3 viewers. Veronica, Javed Sheikh, and Sajida. Good morning, 3 of you. Let's wait until everyone else comes or we start. So I just have to take the chatbot out. Good morning, good morning, good morning, good morning. So the 3 viewers so far. We want to check the stream. Analysis, 0 views. Yeah, it's okay. We're gonna start the session of natural language processing. So in here yesterday we learned about how to use speech to text and AI plugins to make a robot which plays the song, right? Just like Alexa, a voice assistant, plays a song. So now today we're gonna use this block coding. Yes. So the session's outline today, we're gonna understand how NLP works and use AI blocks and PictoBlox to create an NLP model. Make a text classifier that identifies if I want to turn on the lights or off the lights using natural language processing. So yesterday we just did only with one command, right? One input will give only one output. Just like, okay, play the song Mario, and if the keyword matches the program, the soundtrack will play, right? But here we're gonna give multiple inputs. So natural language processing is nothing but like it's a branch of AI that deals with the interaction between computer and humans using natural language. So here we have computer language and natural language. So the difference is like it will have a structure. For suppose if a student completes an assignment using chat GPT, so you can find it like so the chat GPT will have a structure, right, in the pattern. So if I want, okay, let's take an example. I'm gonna open OpenAI chat GPT. So here this will generate the output in a format that an AI so we can tell that the generated output is like AI. Okay, let's select tell me a fun fact. So the result, so here if you observe, it started with here's the one. Okay, and if you want an other, sure. So here if you see here So it starts with a particular pattern, right? See, here's the one. The Roman Empire had sophisticated the efficiency and blah blah, and it just gives the text and ends. Even here in the second output, sure. Did you know the Roman Empire? So it gives the same output as the user likes. Okay, so this is called capturing cookies. Okay, so here you can just tell that okay, this is a computer generated answer, and because it will use these kinds of words like sophisticated, established. So in natural language we won't use that, right? So when we are telling a joke we won't be that much serious about the words and everything. So yeah, so here this natural language processing helps the computer to understand the difference between the computer generated output and the natural language process, right? So we're going to continue. Here we have an example of natural language processing. So in the email filters, we'll get some spam messages, right? Spam emails or spam text. So in the phone in India we generally use a Truecaller. If we get a spam call we can just know because a lot of people tagged it like a spam. But in the email it is like like detecting a spam is not much difficult because the spam emails usually will have the same text for hundreds and hundreds of people, right? And the email is like generated by using AI, or there will be one format, one sort of text, right? So maybe it's an advertisement, maybe it's a offer from another website that okay we are offering discounts or whatever, right? So here the email filters are one of the most basic initial applications of NLP online, right? The natural language. It started with spam filters covering certain words or phrases that signals a spam message. So here even if we write an email using ChatGPT or something just to make the language more proficient, there also the human will leave some marks which are like okay subject is this one, and even in the content there are some little changes, so he won't seriously follow what does the input, right? No, only when he just didn't do the copy paste whatever the AI did. So yeah, it starts out with the spam filters uncovering certain words or phrases. So here we have to consider these the certain words or phrases that have uncovered that spam that signal a spam message, right? Yeah, and there was one more example, smart assistant. So smart assistants like Apple, Siri, Amazon, Alexa recognize patterns in speech, right? As yesterday we discussed, there are lot of modulations, lot of slangs, and a lot of patterns of language that even if we are talking in English, on African, Indian, or someone from Asia, there are a lot of differences in the speech patterns. So then it infer the meaning and provide a useful response. Yeah. Now natural language processing in PictoBlox. So to make a text classifier, we have the natural language processing extension called natural language processing. Okay, let's look at it. So first we have to log in. I'm already logged in. Then go to the left corner, and here we'll find natural language processing. Okay, now we have to download the software. Let's do it. Just open a new tab. So if anyone didn't download PictoBlox, please. So I have to select Windows. If you are using laptop, you can use the Windows, or if you want to download in your Android devices, please go to Play Store. You'll find PictoBlox with Toby's face on it. This icon, the bear icon. So this is Windows 11. So this is enough. 64-bit. So I don't need. So let's just download it. Let it process. Yeah. I've started the download here. Let's open. It's almost done. Okay, in the meanwhile, we'll just discuss. So, what are there in natural language processing block? So, there is a text classifier, and also there is sentiments analyzer, right? So, how many of you watched the movie Robot or Ravan? So, there we can see an example of a robot which has feelings, right? So, and how it got affected. It's just a conspiracy theory, but yeah, why is the quality of the stream is just 480p? Text is barely readable. Sure, sir. We'll just try to analyze it. Just give us few seconds. Okay. In the meanwhile, we can just go through chats here. So the text is barely readable, right? Okay, sir. Will not able to download LLP. Yes, yes. Saida asked like she doesn't not able to download NPL, not natural language processing. It's actually NLP. So you have to download the, if you are using laptop, Saida, you can just download it, the Windows version of it, or if you are using laptop, you can just have Android application. There you will find, because the web app is having only few extensions, but you can't download it there. So just have to wait until this downloads. And yeah, we'll look on how this thing is not 480. So maybe, so try to check your quality analyzer, sir, I guess. So yeah, now next, text classifier using natural language processing. So where this activity is like, have to train PictoBlox to classify a message as turn on lights or turn off lights, right? So then you have to add the palette, the create block of the data lights on. Yeah, now let's install. Let's check. So to make the text classifier, we need the natural language processing. Okay, let it load. The new features like junior blocks for 4+ year children, new paint screen for junior blocks, face detection, human body detection, Vizline. So Vizbot is another robot just like Quarky. So updates on machine learning environment, onboarding screen. So everything is there. So let's see. So in the block coding, let's go with blocks and try to add this extension of natural language processing. So now I'll just log in. So now here you can see this text classifier and sentiments analyzer, right? So get the sentiments of happy, get the sentiments of this analyzation, then get the class, reset the text classifier, add your text as class. So even here we have these blocks. So by using these blocks we have to write this. Yeah, to make the text classifier we need the natural language processing extension that we have already added, and have to take the data for lights. So for that we have to create a function called data for lights on, right? So we know where to add the data. So go to step 3, we use this. First we'll go to my blocks, make a block called data for lights on. And we don't need to take an input of text, boolean or number, right? We just need this data. So this is fine. Now we have to add lights. So here we are training. So this process comes under machine learning in AI. So this machine learning, here we are training the model to process the natural language, which is, so if we say lights on, so for suppose me and my brother are in one room, I'll say brother please turn on the lights, or switch the lights on, or something. And if it is emotional, or it is like not giving the direct command, we can just say it's too dark in here. So the same meaning, right? It's too dark in here. What will we do? We'll turn on the lights. And here I want to study. If the lights are off and then I want to study, I need a light, right? So lights on again. So light is too low, lights on. Turn on the light. Light is too dim. Add on. I need some sunshine. So these are all multiple statements that humans will give while they need light or something, right? We are telling someone, like we are instructing someone to make the lights glow or on, right? So here we are training the model in such a way, we are creating a function where all these commands are set to one keyword, right? Just like in the Google search or ChatGPT, I will give the same output every time. So for suppose I'll just search for weather in Pune. So it's the same output. What if I search in how's the weather? Same output. And it's asking for location. Is it sunny today? So same output, right? So it will give the perception of what the temperature. So yeah, I just want to tell you that there are multiple inputs for the same output. So here the Google search took the input of the keyword, right? So whatever it is, if the sentence has a word whether, how, what, like I want to know about the weather, so all these statements are comes under so the same output, right? So that's how we are training the model in such a way so that it will understand in this way. So add the text like lights on as lights on, and it's to, let's say, it's too dark in here as lights on. Now we're gonna add few more. So I want suggestions from audience, like whoever can give us some inputs that we can add here for the command lights on, please. So in the top chat we have Rubina saying hi. So I need some suggestions, guys. What else we can put here rather than these. So I want to study, light is too low. So let's say light is too low. I want to study. Yeah, guys, I'm looking at the chats. If anyone gives me some suggestions, I'll be very happy to take them. Hi, hello, good morning, good morning, good morning. Good morning again. Any other suggestions for this commands? Replies? I want some sunshine. Technically sunshine is not sunshine, so this means command just on. So what else? Turn on the light. Right, so this is the define block so of a function of data for lights on, right? So we have created this, so this is done. Now for lights off, similarly we just have to create a block of data for lights off and then add all the outputs just like this. I'm just duplicating this block. I have to add one more block for data for lights off, and I'm gonna duplicate the entire block here, put it here, like so. Whatever it is on, we just have to make it off. It's too bright in here. BRIGHT. Bright in here. Then lights off. Then light is too high. Then lights off. I want to study. I don't want to study. Lights off, then I don't want any sunshine. I don't want. Lights off, off, lights off, then turn off the light. So these all set of commands refers to the same meaning, right? So that the human know, but that we are training the program to understand this one, right? Turn off the light, lights is off. Now any chat? Have to check the chat again. Now just receiving good mornings, and in insights I guess there are total 69 viewers, which is a great count, right? Good. Yeah, next so again we have to create a block for defining training the data, reset the classifier, data for lights on, data for lights off. So we are putting all the data of on and off in train data, right? So let's do it. One more block called train data. Put it here. First we have to train the text classifier, right? Then lights on, lights off. No. First we have to put the reset. Have to make sure that the block is empty, right? So that's why we have reset. So now it will train the text classifier according to the process, natural language process. So block 1, block 2, block 3 done. Now let's move on to have to check our text classifier actually works or not. So for that we have to add a green flag. Click the block into scripting area. That have to drag and drop the train data stack below the green flag. Now have to test the classifier working. We'll send 2 new commands for each class, one for lights on, one for lights off, and see the classifier analyzes them correctly or not. And add say block for the looks palette. Inside the say block have to drop a get class off block. So the default time is 2 seconds. Inside the get the class of block, I just say I'm playing but I need to study. So repeat 5 seconds, so it will just get the class of the data. The class of I need to study more. So this is the program for the computer to understand. Like, so we already gave some input to the system, right? So this program will give us the output of what it is understanding. So technically the system is making like statements for us to understand, right? So that's why we have the say block here. Let's do it. When flag is clicked, so you will go to events. When flag is clicked, then we'll train the data, my blocks, train data, then the language block will, okay, first we have to go to looks, take say block, duplicate it here, and you have to put it in get class of I'm playing, get class of I'm not playing. Yes, this won't work, but there is no condition. Okay, let's run the program. Lights off. So we have to give the data like this. In this case, Toby should say first lights off and then lights on. Let's see. Lights on. Lights on. LIGHT, lights on, and then lights off. Okay. We'll put the data in reverse, I guess. Let's check. On and off, yeah, it's correct. So yeah, anyway, it will give the output like this. Lights on, data for lights off, text classifier. Let's see, lights on. Yeah. Okay, generally it's working for 2 seconds. I'm playing and I need to study. Let's check the statements also again. So it's a capital I, maybe that will make a difference. Capital I. So now I have to recheck the program. Lights on, off, too bright, too dark. Yeah, now it's correct. So let's move on to the next. So have to complete the lesson, submit the quiz. So we have downloaded the PictoBlox. Now home automation system. So by using this natural language processing, we're going to create a home automation system where the Quarky will understand to switch on the lights or not. So technically I have to connect the Quarky. So for that, give me 1 second. So yeah, with by using natural language processing, we're gonna have create. Okay, we're gonna create a home automation system by using this Quarky's LED screen here. So the commands which we gave, lights on and off, will work like this. So first let's learn about this, what is home automation and what are the advantages and the applications, and then we go to the activity of just don't delete the program previous program, we can just do it now again. What is home automation? So these days we have different devices such as your phones, laptops, televisions, refrigerators, etc. like can communicate with each other, and all thanks to the internet. So yeah, this is a part of IoT. So you can say it is a combination of AI, ML and IoT project. So the things have become so easy that you can even control your lights and fans using an application of your smartphone, right? So I have my remote in my phone, smartphone, so I can control the AC or some other TV and a projector or something. So yeah, so this is amazing technology which is called home automation, the ability to automate the control of household features, activities and appliances. And these are the advantages of home automation. So you can easily control multiple devices from one place by using your smartphone, and you can control them even with when you are far away from the home, right? Because you are connected to internet anyway, that we have to just do the communication from the smartphone to your household devices through internet. So smart home can help use of energy efficiently, right? Even if you are if you left something open, so if you switch on the TV for too long and nobody's at home, you can just directly switch it off from here, and you can know that that is on even if nobody's at home. And home automation is also help you to save time and money, right? Yeah, and also making human lives more better, right? And the applications of home automation are heating, ventilation, air conditioning, light control systems. So this is our project today, light control system, and home robots in security, smoke detectors, pet and baby care, air quality control, smart kitchen, smart cooking, whatnot. We have a lot of. And now coming to the activity of home automation system. So we know we need the AI extensions for it. So let's go to PictoBlox, get the AI extension, speech, text and face recognition. So we need the internet. So anyway, we have the internet. Let's take one backdrop, a good backdrop which represents our home automation project. I says we have one space city. Yeah, maybe this will work out. Or it is too colorful. Yeah, it's work out. Now extension is added. It requires a internet connection. That's already the permission has been given. Now we are using the recognized speech for seconds in some language block. To understand to analyze the voice from the user for selected time from the drop down, which is 2 seconds, 5 seconds, 10 seconds, 15 seconds, 30 seconds, that you can understand. So this is this block. So the recognized speech for how many seconds that we can control. So this is just to communicate. So how much time we are communicating with the robot, it will give us the output. So it enables PictoBlox to analyze almost 27 different languages. Yeah, and the speech recognition result block will give you the output for the analyzed voice in text. And in NLP, we have already downloaded the NLP extension. It does require internet access, and block of NLP in extension, we all already discussed this in the previous topic. And reset classifier, get classifier, and the script for a home automation system, lights on and off, this we already did it. And script for home automation system, first we have to connect Quarky. So this is the script. Recognize speech for 2 seconds. Okay, I'm gonna put it here. Yes. So if anyone is doing the program, please try to copy the same thing. So we already have the trained data, and we have to remove these blocks. And now we have to put a forever recognize the speech first from the mic. So speech recognition, recognize the speech for, let's say we have statements, right? Let's say 5 seconds. So I'm just changing it for 5 seconds. And if block, we need 2 if blocks. So if get class of speech recognition results is lights on. So here we are using the boolean expressions equals to. So assignment operator, that is. Go to control, if and then block, operators, boolean, if speech recognition recognized class is equals to lights on. So the keyword, basically the keyword. can just take this one, I guess. Recognition is equals to 50. This will work. Then have to connect the quirky first. So for this we need a cable, USB cable, and we are giving the serial output, serial communication port. Switch on the quirky. It's done. Now it's on, and I'm connecting the quirky here. So now it's on. Now let's go to board. I've selected the board quirky and communication 3. So this is connected to COM3. Yeah. So now let's check display. Hello. Yeah, now the quirky is working. Clear screen. Now let's put this quirky light brightness so I'm just putting everything into white. This is white light, and then I'm taking the same if block, and if you want you can just add one say block. So LED is off. Right, this is on, then this is off. So I'm just wanna add one more say block here. So the topic will say lights on for 2 seconds, and duplicate it, put it here. Lights off, and here we have to put the analyzed thing is equals to lights on. So here we are training the model in such a way that it recognizes the speech of whatever the input, and it decodes the speech into text, right? And we are analyzing this text. So here the output, so everything what we speak will go to the functions, right? It will go from here, train data, it will check here. So if the speech recognition result is lights on, so it will go to lights on here, and then check in our data. Lights on and lights off. Let's try. Lights on. Okay, let's try again. I'm gonna run the program. Lights on. Okay, maybe it's not giving us the right output. Okay, let's see it's entering the recognition or not. So recognition window we have for 5 seconds. That's running. The speech recognition result is lights on, then display the matrix. Yes, let's test it again. Lights off. Okay, I'm gonna add one more else block just to check whether it's working or not. So sometimes we have to debug the program more than it need one more if else block. here just to put the result of, and else say I cannot understand. Let's see. And I am here, I am also taking one text, speech to text, text to speech. Oh yeah, now it's running. Lights on. Lights on. Okay, it's having a very less. So lights off.
I cannot.
Lights on. Maybe I have to increase the time of.
I cannot understand.
I just made it 10 seconds. Lights on. Okay, lights off. I cannot understand.
I cannot understand.
Oh, sorry. Oh, it's entering into the else block. Sorry. I just have to put this here. I cannot understand. Yes. If, else, elif. Recognition window is open. Lights on. Okay. So
I cannot understand.
I cannot understand. I want some sunshine.
I cannot understand.
Let's check the data here. Let's debug the program. Here we are checking from train data. So guys, if you have any suggestions or if you find any mistake here, please let me know in the chat bot. I'll be available. Good morning, good morning, good morning. Yeah, first we are taking the trained data, that yes, and text of classifier. Have to set something, I guess. Let's take one variable, and I want to make one more train data and add a text input. Here this is called train data, and I'm just taking one text. I'm not using. Train data text, I'm taking it here, and then data text, and now reset the text classifier that we did, and I'm gonna set my variable to 0, variable to text, yes, and I'm just putting this train data of my variable, so whatever the text we have, and then lights on and lights off. Maybe this will work. The speech recognition result should match. Lights on. Lights on. Okay.
I cannot understand.
It's too dark in here. Just giving one.
I cannot understand.
Let me check. Oh my god. Properties of filter. Hmm. So I guess set language is done. It's not. I cannot understand speaking. Let's say lights on, and let's check the PPT again. So maybe get class of speech.
I cannot understand.
Maybe this will work. Get class of speech recognition, which is in AI. And also we don't need the variable to assist. We can block with I guess my keyboard is not working. Just set it to my variable. So in the blocks we have lights on and lights off data. Now maybe it will work. Let me check my keyboard is not taking any input. So I just want to save file as lights on. Now it's working. Okay, sorry. Yeah. It's too dark in here. Great. I don't want to study. Great. So this is how we are training the data. So whatever the output is in here, it's from the class. So I just made a mistake of I didn't put get class of the speech recognition result. So let's test it again. The light is too high. Very good. I want some sunshine. See, so that's how it is working. The robot. So here you can just put something else like forever loop, or it will take your continuous. You can add more here just to train the data. You can add more this thing. So if you have any other suggestions to modify this kind of program, just please let me know. I'll just put lights on and off rather than okay. I just want to check everything. So it's too bright in here. Great. So this is how, even if we didn't connect, so you can actually connect it with using PictoBlox link by using this Bluetooth option. So we need this PictoBlox links to be installed if you want to run through this Bluetooth, so that you can place wherever this robot in your like range of Bluetooth, and then you can write this program, then it will work, right? So speech analyzer is done. So let's have a break of 5 minutes. Yes, and then you can let's go to the next topic. If you have any other doubts regarding this project, I'll just display this for a while. So if you want to take any screenshot or want to work out again in this one, you can just do it. So I just made a different block. I didn't put the block name, that's why it's like that. And this is the entire program, and try to interact. In the meanwhile, I just have the chat bar open. So this is the activity. So we can add emotions like happy in programming. It will show the quirky when say it. Yeah, it's a good idea. Yeah. Let's do it. You can also add emotions. So I am sad, I am happy here. In okay, there is one more. This one. So get sentiment. So you can add this sentiment block, and you can make one the emotion recognition bot, and then you can connect with this quirky, and then make the emotions like whatever. So whatever you put in the block, it will run, right? So yeah, so let's have a break of 5 minutes. If you want to have a look on the program, you are just free to open, and then you can yeah, I'll be open. Thank you, Samina, Sheikh Samina, for giving a good idea. So thank you for interacting. So please note down the program. I'll be available here. Display. It's too bright in here. I don't want sunshine. You want to try?
Lights on. Lights on. Lights off. Lights off. Off.
Off. Lights off. It's too bright in here. Okay, welcome back after the break. So we have next topic as introduction to machine learning. So we already did the projects using machine learning, but let's learn about the theory in it. So in this session, the outline is we have to learn about machine learning, teachable machines, training the data, and machine learning in PictoBlox. So let's create a cat versus dog training model for machine learning, and thus we have to train the model according to that, right? So let's take Humans learn through these 4 steps, right? We're just recalling the topic, right? So we have sensing environment, analyzing information, decide and act, and increase knowledge. So these are the 4 steps that humans will learn. First will sense the environment. Okay, if I'm in a classroom or if I am on a system, so I'll just analyze the environment, like, okay, this is a monitor where I can see, this is a keyboard, I'll type, this is the mouse where I move the cursor, right? And we have here, this is called analyzing the information, the what I know, what I don't know. After that, we will decide and act. So okay, I know till here and I have to learn this, right? And then we'll learn that part that we didn't know, and we'll decide and we act accordingly. And then after learning, we increase our knowledge, right? So these are the 4 steps of the process, where we have sensing environment, the first one. So we have first take the information about the objects available in our environment through our 5 senses, like vision, touch, smell, taste, sound. So these are 5 sensory organs that human will have. Just like that, machines will have some sensors that we're gonna learn in later on process. So it will, like, in the process there is analyzing information. The next step is to analyze the information gathered from our senses using our previous knowledge, just like identifying the objects like a dog, a house, a car, etc., and deciding and acting. In this step, we are using the knowledge and information about the object, and we are deciding what to do. So for example, if it's a cat, we want to play with it, but if it's a tiger, we will run. So yeah, this is called deciding and acting. And then increase the knowledge. Humans learn from the output of the last step. So for example, if you decide to play with a cat, but the cat scratched you, then you would register to the particular cat as not a friendly cat and increase your knowledge accordingly, right? So that's how machines learn. Machine learning is a process of machine learns how to act by themselves without any human intervention. So it's basically getting a computer to perform a task without explicitly being programmed to do so. So let's go to chat box if anyone has any doubt. Motel 999 gaming, great. So Parveen Dalal, okay. Assalamu alaikum, walaikum assalam. Yeah, okay. So it's basically getting a computer to perform a task without explicitly being programmed to do so. And in the machine learning model, there are 3 steps, like input, model, and output. In input, the image or sound of information into the model, and then model algorithm operates on the input to output in higher level information. Based on the output, the machine takes the decisions and act accordingly. So there is one more software that we are going to use rather than PictoBlox. That is called Teachable machines. So Teachable machine is a tool that makes it fast and easy to create machine learning models for your projects. So what is more, it does not require any coding, making it a perfect for beginners with no or a little coding experience to learn machine learning. So you can train a computer to recognize your image, sound, pose, export the model for PictoBlox. So it's like a extra tool, just like we have extensions. So the types of model that we can make are image model. So teach the model to classify images from your files or your webcam. Me plus dog or just me. So here the percentage is like if you take the scale 1 to 100, so me plus dog has a greater match than just me, right? So in the audio, teach a model to classify the audio recordings or short down based on the short sound samples. So this is snap and a clap. So teach the model to classify body positions from your file or streaking poses in your webcam. So this is mostly stand and little percentage of squat also. So cat versus dog, training data for machine learning. So downloading the data from here, it's like cat versus dog. So unzip the folder to view the images and folders inside. So we have our data already left, cats versus dog. So just clicking the link here. So if anyone wants to do, you can just copy this URL. You can just directly download it, or I'll just put this in the comment box. Let's open. So I am putting this file in the comment box. You can just directly click on the link and download. So the folder has the following folders inside it. One is training dog and next is testing data. So 10 cat images, 10 dog images. So let's extract it. So it's still downloading, I guess. It's 349 KB. Yeah, now it's done. Let's open the file. So extract here. Yeah, now we got this file. So 10 training data and 10 testing data is there. So let's keep it aside. So now we have to go to Teachable machine with Google and then get started button. A new page will open. Get started. Okay, I'm gonna put this one as well in the comment box. So first link is for content, second one is for training the data. So Teachable machine is next one. After that, now click the image project title and then we have to upload the images. So let's go. This is image project. It's a standard image model. Then here you have two webcam and upload options. Let's train it with webcam. So class 1 is the category in the where machine learning models classify the images similar to the images that are put in one class. Okay, and there are two things that you have to provide in the class. One is class name and one is image data. The data can either be taken from the webcam or uploading from the local storage drive. So first we have to put in the class 1 the data, and the class 2 is another one, and then we train the model just like you see here and the preview. So let's rename the class as cat and upload button. Then we have to upload the images. Now upload the folders. You can just drag and drop it here. So here we have cat files. I have to select all these. Okay. So we got 10 samples of cat, right? Then once uploaded, you will be able to see the images in the class. Then rename the second class as dog, and we have to add the dog's images there. So let's go to class 2, name dogs, upload the images, and just directly go here, drag and drop the files. So we have cats and dogs here. Now cats versus dogs, training the model. Now for training the model, we have to click advanced button to see the advanced settings, and then there you will find these extra epochs, the batch size, learning rate. So here we'll just get to know detail about it. Let's see. So in the advanced we have this epoch, batch size and learning rate. So epoch is nothing but the number of epoch is a parameter that defines the number of times that the learning algorithm will work through the entire training database, right? So one epoch means the each sample in the training data sheets has a single opportunity to update the internal model parameters, right? So it's just nothing but the parameters that define the number of times the learning algorithm will work through the entire training data set, right? And batch size is the total number of training examples present in a single batch, and learning rate is a tuning parameter in an optimization algorithm that determines the step size of each iteration while moving towards the optimization of parameter. So how fast the machine has to learn, we can just put it in learning rate. And now training the model. To train the model, we have to click on train model button, and then you have to wait until this one will happen, and we can see webcam on. Once the train, you can see the following preview title to the test model. So here like this, let's do it. Let's train model. Model is preparing the training data, so just loading how they will work. So let's see, and the model is already trained, and you can see here in the output how many cats and how many dogs are there. So this is just showing me as a dog. So let's see, I have a picture of my dog with me. So let's this is my dog. So let's try to test it. it's in the other pose, that's why it just not matching the output. Let's try again. So maybe the output is blood. Just give me 1 second. I'll just open it. Yeah, let's test this one. So yeah, now it is detecting 100% dog, right? So as you can see in the model, so this is how it will detect the faces by using uh, the models that have been trained here. So it's a live example. Now you can just export the model and click on the file. So this is to test. And again, and another testing method is like by uploading the testing files, click the upload setting as shown in the image above. Let's see how many models that we are going to perform, and just have to export the model. After to export the model, click on export model button so that you can import the trained model into the PictoBlox, and then click on export, and one pop-up will be opened like upload my model button. So in the TensorFlow, one link will be copied. So let's do it. Exporting the model. So here you can have this link, this teachable machine, this link we have to copy. Models dot yeah, now it's downloaded. We have copied after uploading this one, the link is copied, and then we have link will be copied, yes, and then this link is used the machine learning mode. So now let's go to PictoBlox, open a new file. Machine learning environment. Here we have to take ML with teachable machine. So this extension we have already teachable machine. We have to load a model, and we have to paste the same link here. Image or post, there are two types. Just load the model. Now the model loaded successfully. There are two inputs, so they are cat and dog. So as we have given there, cat and dog, and as identification classes, webcam in the cat, and identify if they have identified the cat. So what should we do? Then we have to write a program in the PictoBlox. So anyway, our time's up. So I hope you have enjoyed the today's class. Tomorrow we're gonna have one exciting this cats and dogs project, which is machine learning part 2. So let's save it for tomorrow. Today you have learned how to do the natural language processing using AI and machine learning a little bit. So how to train the model, and then now how to use teachable machines and analyzing a pose. So yeah, that's it for today. If you have any doubts, we have 1 more minute. I just want to know. There are only my links are there in the chat. So yeah, no, anyway, the time is up. So you're gonna have the next session on uh, blockchain, and you can have a break of 15 minutes. So next class is gonna start in by 10:45. So thank you guys. Have a break of 15 minutes. Thank you so much for your time. If you have any queries, I'm just you can reach me out in the WhatsApp group or somewhere. So thank you. Have a good day.
Yeah, good morning, everybody. I hope you all are here. Please let me know with your chat, use the chat box to let me know if I'm audible and if we can start a class or not. Yeah. So I think that is perfect. I request you all to please put it in the chat box if I'm audible or not. Yeah, good morning. I really hope I'm audible. Please let me know in the chat box so that I can start off my class. Yeah, it's audible. Great. Thank you so much. So, all these days, we have been discussing about the conscientious mechanism where it is nothing but where everybody will come to one single agreement and everybody will follow the same. So, we have heard this word, but are we even using it, or we are going to learn deep about it and how it is included in blockchain and how we can put it in blockchain. Okay, so this will be our today's session. And yesterday I think I gave a small activity, and I hope at least one of y'all came up with it. I want you all to put it in the chat box, and I'll be waiting for the same. Please put it in the chat box, at least one person from your end, and at least I will know that you are concentrating in the class or so. The activity was nothing but making kids understand blockchain using hypothetical situations, where I came up with something called voting system. I wanted you all to do that, and I request you all to please put the same in the chat box so that I can assess them, and maybe we can discuss it all over. If you didn't come up, at least say couldn't, or you didn't do the activity, or you didn't come up with one, because I don't want to proceed before that, because every class it cannot be the same. About ethical implications. Yes, perfect. About ethical implications. So how many of you all have come up with at least one idea? Please put it in the chat box. So I would not like to proceed, but then as due to the lag and all, I don't want to waste that much of time. But if you have any, please put it in the chat box, and I will start off with our today's class, that is conscientious mechanisms. So let's read the definition first. Conscientious mechanisms are protocol used in blockchain network to achieve agreement among distributed nodes on validity of transactions. So again, coming back to the same point, circling back to the same point, conscientious mechanism is nothing but coming to an agreement where every person connected to that node will accept whatever is going on. So that is the basic thing, and please remember that simple definition and make a note of it in your books or wherever you have been doing it. So once you make a note of it, you'll understand whenever we discuss the other topics related to this, you have to circle back to this point where we all will be coming to an agreement. So I hope you're all noting it down, and I hope you're clear with the simple term, that is, it is nothing but achieving agreement among the nodes. Or so far we have discussed this like it's between people or so, right? So far we have discussed it's with people. So far we were talking about general agreements about among the people, as computers don't have any point of views, they don't have any a certain set of things to think about and come up with one ethical plan or so. Let's now dive deep into the actual terms, and no more people and no more things. Here it is nodes. Nodes indicate the system or the computer which is connected in that particular blockchain. So whenever from now on we will be discussing about nodes, It's not the people or it's not the connections, it's simply the computers. The computers which a human might be managing, but yet it is a computer, and that is how we are going to learn about the same. I hope I'm clear so far. So there are 10 types of conscientious mechanisms. So I want you all to make a note of them. Make sure you make a note of them. First one is proof of work. Please let me know if it's visible or not. Otherwise, I'll make sure I'll zoom it enough. Please let me know if it's visible or not. Otherwise, I will zoom it and we'll discuss. Please put it in the chat box if it's visible, because there are few things which are little, not so clear. Please let me know if it's visible or not, so that I will be zooming it, or I'll continue. I request you all to put it in the chat box. I hope it is visible enough and I don't have to zoom it. So anyways, so I will keep going as I did not get any answer so far. Anyways, the first thing is proof of work. Please zoom in, ma'am. Yes, perfect. That's what I wanted to ask at the same time. Yeah. So we will go 5 by 5. I hope that will be fine. Just give me a second. So I think that should be good enough, and it should be visible. Just give me a second. Yeah. So the first one is proof of work. So I didn't give it in the presentations. I will be giving you the definitions like right here, and I request you to note them down no matter what, and I will read them for you. So proof of work in blockchain. Okay, I hope it's clear enough. So first make a note of these three and then I'll get back. First thing is proof of work, second thing is proof of stake, and the third thing is delegated proof of stake. So we will discuss all the three in detail. Yeah, thank you, ma'am. Great. So first, So first thing, proof of work. First thing, what is proof of work? What is work? Work is something that has been done. And what is proof? A thing or a valid thing that can prove that you have been doing some certain set of work. So here, when we talk about blockchain and when we talk about this conscientious mechanism, here proof of work indicates the transaction taking place. Simple. So as we know, blockchains are all about simple transactions. They are all about a transaction taking place and how the data is stored and how it is put into action or so. So now I will be telling you the definition for proof of work. I will also type it, but I request you all to please note down the same. Okay? So proof of work. Proof of work is a technique used by cryptocurrencies to verify the accuracy of new transactions that are added to a blockchain. So I'm also typing it down here so that you'll have a reference, and I request you all to please note it down. QUE used. So I have put the definition in the chat box. Please make a note, and every definition here so on is important. And I will be giving an assignment today for sure with all the concepts discussed so far, and I request you all to please make a note, because all these are going to be in the assignments or the test which you will be taking taking for getting the certifications as well. So first thing is proof of work, and proof of work is nothing but it is a technique used by cryptocurrencies mainly. It's not just the cryptocurrencies, but here we take the cryptocurrency as the biggest example, so that it's very easy to understand. To verify the accuracy of new transactions that are added to a blockchain, it's simply adding a transaction to a blockchain. So when we come to this proof of stake, I want you all to answer what is stake. I will be waiting for the answer. I want you all to answer what is a stake in general terms and not in a form of blockchain. I want you to answer the same. I want you to answer what is stake in your own terms. In general terms, it doesn't have to be anything related to blockchain. Please make it interactive. I request you to please make it interactive. Stake in general terms. I'm not asking even a big question that it's not answerable. I request you all to please put it in the chat box. What is stake? Before I go and explain you what is proof of stake in our blockchain, I request you all to please put up a message about what is stake. It's a sincere request. Please put up a message about what is stake so that I can keep going into the same. Amount of cryptocurrency. Okay, yeah. I'm not asking again in blockchain terms, but stake is nothing but something which has a value. And let's say this is my stake, and let's say let's talk in a very general term. In a pizza, this is my stake. So those two pieces are my stake. So something which has a value and which you can say you can assign it to some person. Okay. So that is known as stake. But when you look at the definition, see here proof of work is nothing but making new transactions, and proof of stake is nothing but verifying those new transactions. Got it? Proof of work was again making new transactions, and proof of stake is nothing but verifying those new transactions. So the next part is delegated proof of stake. What is this delegated proof of stake? It means the same, no? Like the proof of stake is okay, but then what is delegated? As we were speaking before, here we are no more going to discuss about people or opinions or agreements or so. Right? So today we are simply going to discuss only about the computers and the nodes. So here, let's say in a blockchain which I have, there are around some 20 systems connected together. So let's say only 7 or 8 of them are active enough, right? When 7 or 8 of them are active, we can say like they can mine, or they can check these transactions which are done. They can verify yes or no. Only the ones which are active. If the rest computers are turned off, do you think you can do something about it? No. So when we talk about, again, conscientious mechanism here, the active nodes, the active computers, whichever are there, they will be voted among themselves that who will be taking care of this mining process or verifying these mining processes. So when the voting takes place here, right? One second. Yeah. I'm trying to give you the definition so that you can note it down, because in this we just gave up only with the numbers, I mean only with the names, but then I don't think you're you won't be able to get the perfect definition. So I'm trying to give you the perfect definitions. I'll be typing all of them in the chat box. So yeah. Again, as I was telling, in delegated proof of stake, let's say some certain set of systems are turned on, so they vote among themselves where who is going to take care of the mining. And when they elect the people who got elected, or the people who are won, or like the votings are done, they are called as delegates, and they are the one who will take care of the next coming transactions or so. So I am typing the same. One second. A block. I request you all to please make a note of whatever I am giving. These topics are very much important, and like the whole subject might be revolving around this. As I was talking, it's no more about the people, it's more about the computers. And that is where the difference comes from. If we talk about people, you might not understand. Sorry, hold, I didn't get your point. Okay, anyways, I didn't get the point. Please try to make it clear. I request you all to note down all the three so far. So we'll discuss 5 at a time and 5 at a time, like in a better way. And then we are going to come up with an activity today in which we can make these even better. So probably I will be telling for 4 of them, and I request you to tell for all the others. And here today, I'm no matter what, I will wait for your answers. And no matter what, I would request the same from you, that you should be giving the answers for the activity so far, because every day it's simply going off without your interaction. It's just the the question and answer, but I want you all to think out of the box and come up with nice activities. I will let you know what is it in the end of the class, but meanwhile let's discuss about things going on. So far we discussed about proof of work, we discussed about proof of stake, and delegated proof of stake. So what was the difference between all of them? First one was, it was simply making a new transaction. Stake was again verifying the transaction, and delegated proof is who will verify these. Of course, like when it comes to proof of stake, it's how do I tell you? When it comes to proof of stake, it's like verifying, but then it's not completely verified if it's repeated or so. It's verified that if it's a transaction or not. But here, the delegated proof of stake is the voting system, where all these verified things will be validated and then added into the block. So the next one is the proof of activity. Proof of activity is nothing but the combination of proof of work and proof of stake mechanism. So it's like simply noting down that the transaction took place, and then the transaction is verified, and the transaction has been assigned to these people or these miners, that is the voting was taking place, right? So these miners, they have to do these complicated mathematical computations. As I was telling you, they will be solving simply, like they'll be solving many algorithms, right? And by solving them, they will let's say you're doing a cryptocurrency. The miner, he or she needs to solve all those computational solving problems, not humanly, but using the computers again. So when they do that, both work and stake are seeming almost linked. Kindly differentiate. Yes, here in proof of work, just the transaction takes place. It's just like the transaction number. But in proof of stake, the transaction is validated. That is, did it go from A to B, or did it go from A to D? And is the transaction of data, or is the transaction of some money, or how it is done? So in proof of work, it's just the transaction. In proof of stake, it is verified if it's the transaction is it's done or not. Here, verify the accuracy in the sense, see, when we talk about the definition, to verify the accuracy of new transaction, that is nothing but when, let's say, in a cryptocurrency you're trying to mine, okay, and I made sure I mined one cryptocurrency, that is Bitcoin or so. So yes, I mined one and done, it's there. So is it validated? We never know, right? So proof of stake is verifying if it is mined or not, if it is done or not. Here, according to the definition, verifying the accuracy, that means is it done, like the transaction took place or not? Is it a new transaction or not? Done? Okay. And where is whereas in stake, verify the cryptocurrency transaction. Yes, stake, in proof of stake, it verifies if it is proper, if the transaction took place, and is it repeated or not. And in this delegated, once the repetition is checked, these delegates will verify which block it's need to be added, which who will be taking care in delegated proof of stake, right? So I hope you understood the difference now. And let's go, as I was telling, proof of activity, I'm just putting as POA. I hope you will understand. Yeah, POA is the combination of POW and POS. So it's very simple. I request you all to please make a note or something, because proof of activity is not that tough. It's simply the combination of these two. And then comes proof of authority. So I would say this proof of authority is related to the delegated proof of stake. So let me tell you how. In delegated proof of stake, we were telling that the network, in the network, the users will vote and elect some people to validate these transactions, right? So this proof of authority is nothing but the people who are going to become these validators, right? They are already pre-chosen, now they're chosen. Now these are called validators. So the proof of authority is nothing but the people who are validating them, or the computers who are validating. So I am again writing down PO authority. Stake means hold of something. Yes, correct. Oh, I think it's too laggy that I got this answer after so long. It's okay. I'm typing the definition for proof of authority. As I told, for whatever we have already elected in the delegated proof of stake, they are known, they are called as miners, I mean they are called as the validators, as we or the people in the network or in the computers, the nodes in the network have like what we say, they have elected that these people are active and they will be doing the validation process, and this will encourage all the miners to take a part in this of I'm just putting the definition, please choose in ch. Yeah. Your audio is not clear. Okay, I'll try to be more louder, and let me just try it with turning off the mic or so. Clear now? Please let me know the same. So this is the definition of proof of authority. I am making a note and I'm typing every single thing because these are very important, and I request you to please make sure you note them as well. Okay? So please make sure you note every definition and also the side headings which are given, because you might get, I mean, these things are very confusing. As somebody asked, proof of work and stakes look like the same thing, but no. Proof of work is just a transaction and proof of stake is verifying the transaction. So that is the reason you should know the difference very well, and make sure you note down these in a better way so that you will be able to solve your assignments or so. Okay, so let's go on, and coming to this proof of burn. As I told, proof of authority is nothing but the validators. Now, proof of burn, it's like, let's say we have 10 people in a blockchain already, and let's say they are mining a cryptocurrency, and let's say for the first crypto coin that they want to mine, it might take some 30 days of time. I'm just taking an example. It should not be completely true. It can be varying from many other things. Okay, so let's say for one thing I took 27 days. Great. And when I, like myself as a miner, when I want to generate the second coin, it will take only 27 days only. Before it was 30 days, now it will take 27 days. So the time reduction, the burning of energy reduction is nothing but proof of burn. So what happens if we do this in a consensus mechanism? It will encourage new people to join. First of all, it will encourage the old miners to remain in this in order to validate all the transactions in a blockchain, right? I hope I make sense. So I'm just putting off the definition also. Once you read the definition, you might understand it even more clear. In offline classes, I can simply read it to you and ask you to note, but here, as I don't see you people, that is the reason I'm typing it. Periodic bonding. And there is one more here, that is, let's say a person started mining a coin, okay, and he or she has left it in between. So now what happened to the crypto coin which has been mined? It's half mined, right? So do you think that it is useful in any way? No, right? So here it is periodically burnt, like the partially mined or the ones which are not being used, they are burned so that it will motivate the new miners to join in, and it will give scope for them to solve, because they'll have some period, like they'll wait for a while or so, and once there is no activity from the miner, they simply burn it up. So but the initial thing of proof of burn is it promotes periodic burning of coins to avoid partiality among new and old network participants. So it means it's like the virtual power, the power which we use for mining, right? reduces each time a new block gets mined. So it motivates miners to make regular transactions instead of like just one time investment, right? It's not like just one time they'll come in and they'll like maybe mine and they'll just whatever they get they'll go. No, it's not like this. So this is like the periodic burn of energy, that we will be reducing the energy in order to keep the miners active. I hope you got the point. If you have any questions or even a little confusion, please let me know. And you can do your own research for the same among yourselves, to understand it even better. Anyways, once we go with the activity part, we will be able to understand it even better way. So like, of course, that will make it clear, but then still, even if you have a single doubt regarding the same, please put it in the chat box. If you're clear with the things so far, please try to keep it interactive. We are requesting them to keep it like a Google Meet where we all can actually interact face to face. So, and also it would be great if you can put it in the chat box that we would be interested in Google Meet, so that we can show them these responses and we can try to have a Google Meet to make it more interactive. So please put it in the chat box. That would be really, really helpful for both of us. So that's a sincere request. And meanwhile, if you have any doubts for the first 6 topics so far, we discussed about proof of work, we discussed about proof of stake, we discussed about delegated proof of stake, proof of activity, proof of authority, and last but not least, proof of burn. So proof of burn, it indicates 2 things. So the one thing is the periodic burn of the energy, like the reduction of energy every time a new miner joins, and also like the old miner will be having reduced time, that is encouraging them to keep them active in the blockchain instead of just like one time investment, they came and they went. So proof of burn will actually help the blockchain to keep it active no matter what. What is the meaning by burning? Burning is nothing but, in general, we know burning is something which is not there, which is like burnt and we can't get it back, right? So just like that, yeah, it is destroying. Yeah, what is it? It's not destroying. It's here it means reducing. See, there are 2 meanings. First thing is in burning, like it is reducing the time. When you are trying to mine one more coin, let's say you mine 10 so far and you are mining 11th coin, the time took for the 11th coin will be less compared to the time took for all the 10 coins you were mining. I hope you got the point. So that is burning of time, reducing the time. That is one thing. Second thing, burning means destroying, where in this again, which indicates, let's say a coin, this only gets in cryptocurrency, it won't be getting in any other thing. Let's say a person came up with that he wanted to do cryptocurrency and he mined only partially, half of it. So when only half of it is mined, there is there's no way you can use it or you can reduce it, like remove it. So there will be a periodic time where all these partially mined cryptocurrencies or these are burnt away, that is destroyed away. And so that you are creating space, you're creating space for other people to join in, you're creating space for the miners to be more active, and that is how it goes on. Is proof of capacity. I hope you understood the proof of burn. There are 2 meanings and 2 things, but the original definitions remains the same, that the time taken to mine first coin is more compared to time taken to the mining for the second coin, that is burning of time. So here proof of burn means burning of time, and in general terms reducing the time. So that is it, and let's go to proof of capacity. Here proof of capacity is like the alternative solution to the problem by proof of work or proof of stake. So it uses the storage capacity for mining a block in a decentralized network. So let's say a person wants to mine Bitcoin. So don't you think he or she needs to have certain set of storage in order to store those Bitcoins also? right? So here proof of work and proof of stake are like the transaction and verifying the transaction. But what do we do with that? What do we do with that? So we have to store it somewhere, right? So I will type again for you the whole thing. So please make a note of all these. So I want you all to answer what do you think are the problems placed problems by proof of work and proof of stake. Proof of stake. So I have put up even the the definition for proof of capacity. So please make a note. It's like once you make a transaction, verify the transaction, what do we do with it? So it's like the alternative solution, that is proof of capacity, where you can store. By the name itself only we understand it very well, so that you will have to save the data, right? So it uses the storage capacity for mining a block. So simply when you are giving when you're allowing one person to join your network, these are the prerequisites that he or she needs to have certain set of storage, such as hard disk or USBs or like whatever things which are connected to the computer, in order to store the mined data or the bitcoins, the currencies which we have. So the next one is proof of elapsed time. First of all, I'll just read the definition. Like, first of all, what is time? We all know what is time. So when we go deep into it, it's like a mechanism that is used for only certain set of blocks, blockchain network, to decide mining rights. So this can be like, example, let's say in a school, or when you are trying to how do we say, let's say you are supposed to mine something. Let's say you have I have like 3 to 4 participants right in front of me, and each person has different specifications of computer. So here, whichever takes the least time to solve my problem, whichever the thing which I am taking, so they will be considered as winners. So it will help you identify the perfect miners. It will help you giving the rights to the miners who can actually get it solved, who can actually mine the cryptocurrency, right? So it's like you'll have to prove to them that you are the person who can mine, right? So I hope you got it. I'll again put up a definition so that you will understand. Okay. Again, when I'm talking about these, I want you all to relate to the mechanism that is coming to one single point, where everybody will agree. How can everybody agree on certain set of points? So here, let me type it so that you'll make a note, and whatever I am giving in the chat box, I request you all to note down, no matter what. Please make a note of these, not just taking a picture or not just having it in your phones, because we all know that won't be helping us, right? So let's say there are hundreds of people who came to mine. So do you think you can give the mining rights to everybody? No, right? Because they might not have proper equipment, they might not be the right people, they might be trying to do the frauds or many others. So in order to prove, like in order to get the perfect miners, this proof of elapsed time is one of the biggest thing which is used in blockchain networks. So I have put up the definition, in the chat box of proof of elapsed time. So it's like a mechanism used on permission blockchain. Let's say one whole blockchain, which is mine, maybe I have 10. So, and 100 other people are interested to join. I can't simply give every other person to join it, right? So I might ask them to solve a certain set of problem, and whoever does it first will be decided to do the mining, else they won't be allowed to do the mining. So this also is dependent on the capacity. If the miner or whoever is there, if they are able to if they are able to give that amount of storage in order to store your data, then only he or she can be given the miner rights, or he or she can be selected as the mining person. So elapsed time is also similar to this. It's dependent on them, and the capacity and the elapsed time both are interlinked, and these are the main consensus mechanisms which decide who will be doing the mining part of the work. So yeah, if you have any questions, please let me know while I move on, because once we are done with this, it's going to be a different topic. The last one is the last but not the least, it's like the proof of history. What is proof of history? It's a cryptographically secure and it's a verifiable sequence of hashes to order transactions and blocks in a blockchain network. So history, let's say this cryptocurrency got mined first, so that should be kept before. So with the in history it's all about the hashes and all about the information that is there, with which they are put sequentially, they are verified sequentially. So this one, okay, I'll just put a heading also, POH. It relies please, again and again I'm repeating the same thing. Please make sure you note down all the definitions, because they all look similar but they are all different things, and these definitions will help you answer them. So I have put it in the chat box. I request you to please check. This is proof of history. It is where it's like a cryptographically secure and verifiable sequence of hashes to order transactions. So keep them in order, and blocks. Of course, like once a set of transactions are kept in one place, that will become a block, which we already discussed. So please make sure you're noting down all the definitions. And we have one more thing which will come back, where the activity part we will discuss in the end, because I don't want to waste time, and here it is not interactive like the offline sessions. So if it's interactive, you can come up with even better activities. That's my genuine opinion. So I request again, I repeat, if you are interested in the meet, so please put it in the chat box. Yes, we are interested in a Google Meet link, or we are interested in a meeting in a Zoom meet, so that we can make it interactive. Please put it in the chat box so that we can have it as a reference, and we can request them to add one where we can have a interactive session. So yeah, the next one is proof of importance. So what is this proof of importance? What is importance? Importance is nothing but something which has some certain set of value. Yeah, sorry. So when we talk about this proof of importance is nothing but something which is, which is supposed to be given value for, something which you need to work on it, right? Like something which is important, like in general words. So it works to prove utility. So I want you all to answer, what is the word utility? What is the word utility? Please put it in the chat box. This one, I request you to please put it in the chat box. It's very much required. Something valuable, yes. I'm asking, what is utility? I request you all to please put it in the chat box. What is utility in your own words? It doesn't have to be in the terms of blockchain or so. It can be anything which you would be knowing. Usage, yes, the things which can be used, perfect. So utility is nothing but using of certain set of things, like the service it provides or the things it can actually do, right? So here in the in cryptocurrency especially, so let's say we all know, right, to mine a small bitcoin you need to have a proper a system, a proper thing with a graphing card, a proper storage capacity, and everything needs to be pre-kept in order to mine or even start mining one cryptocurrency, or even like a lot of energy, right? So all these together, it's like it is the importance where all these utility in the nodes are nothing but computers, as we are discussing. So I just put the definition. It works to the utility of nodes in a cryptocurrency system so that they can create blocks. So all the predefined things, that it has certain set of storage, it can work. Let's say when we talk about this, let's say a cryptocurrency takes some certain set of time, and your computer should be able to handle, let's say you have your brain, can it work 72 hours straight without a break? No. So just like that, even computers have certain set of range where it can work continuously. So if all these things are met, then only that node can be used to generate or mine cryptocurrency. So it is the utility, it is the service, it is the things you can use in the computer, in the node, in order to create a block. So I am just giving you a minute. Please let me know if you understood this or if you have any questions. So yeah, I request you all, if you have any questions, please let me know. If I can continue to the next part or not. If you have any questions, please make sure you ask it right away. We will do the activity later on. So now we have discussed so many, right? Proof of elapsed time, proof of history, proof of importance, proof of work, proof of stake, delegated proof of stake, etc., etc. But then by achieving all of them, what are we actually going to get? So that is the main question here. By achieving all of them, by achieving all of them using, there's the thing like all these together make one conscientious mechanism. So what can we achieve? What is the importance of it? The first thing is agreement on valid data. So let's say first, proof of work, a transaction took place, and the second thing, proof of stake, it is verified. Second thing, miners check and validate, and that validated stuff can be stored, that is proof of capacity, and they have enough of proof of history. I have already given it. I'm putting it again. Please make sure you note it down. I have given it again, proof of history. I'll just make it write better. Yeah, I have given it again, proof of history. It relies on cryptographically secure and verified sequence hashes to order transaction and blocks in a blockchain network. That is the definition of it. So yeah, as we are discussing, when we achieve all of this, first thing is agreement on valid data. So when we talk about this valid data, I mean to say that first thing, it is verified. Second thing, it's validated. Third thing, it is stored. Fourth thing, it was being able to mine with all the utilities. So isn't it easy for everybody to agree on it, because everything is taken care of, right? So that is the first point, that we'll be agreeing on some data. Where disagreements, there is no chance, right? Once you verify everything, once you have everything sorted out, you put it clear enough. So there is no point in having a disagreement. So that is how we all come to an agreement. So by achieving this consensus mechanism, first thing, it's very easy, and everybody will be agreeing on the valid data, and not just like the random agreement of the nodes where the data is valid enough. The second one is aligning incentives participants. So what is this aligning incentive participants? What is incentive? In your words, let me know what is incentive. I'll wait for a minute. Tell me what is incentive. I am not asking in the terms of blockchain. I am asking in the terms of general incentives. What is incentive? Anyways, okay, so I don't know, but I think there's a lag and I'm not getting answers. But before that, I'll just tell you, incentive is nothing but a extra thing people get paid for doing a good job or doing a better job, right? So alignment in general terms is nothing but keeping them in order. So here, by achieving consensus mechanism, how is it benefiting? So the thing is return. Okay, it's not return, but it's something extra things. Yes, perfect answer. So coming to this, incentives are important for blockchain network because they help to align the interest of participants with the desired outcomes for a network. So let's say we have one blockchain network and its main thing is to maintain security. Okay, so once, okay, just give me a second. Yeah. So once this network, let's say I am building one blockchain network where my main motto is to have security, secure transactions also. So, let's say if I have 10 people in the blockchain, if they are not doing anything like censoring, they are not doing anything like sharing my data to somebody, or they're not doing any falsifying like duplicating, they're not trying to do anything like that, and they are being good in the blockchain, so I will give them incentive. So that incentive can be maybe like let's say to mine one block cryptocurrency, you'll take 27 days, so I can give them a 3-hour incentive for following all the rules and for not putting bad things in it, like to prevent attackers and by preventing the data to go out also. So once if a person, a miner or a node, if it is following all of them, that node will be given incentives. I hope you got it. This will help you, what do we say? This will help us to achieve our goals, to achieve a network's point of view. Let's say if it's there for security and preventing attacks, you can simply give them incentives whenever they are making sure that all the miners are making sure that this is not happening, right? So the next one is prevent double spending. So I want you all to tell me, what do you think is prevent double spending? What is double spending in your words? What is spending? What is double spending? Just let me know your answers. We will move further in the same thing. What is spending or what is double spending in your own words, in regular terms? So yeah, I think I should wait for the answer, but before that I'll just give you a small description about the same. So let's say double spending is nothing but the thing which is duplicated. So it means the same unit of currency could be spent twice. So if there is double spending and if people can use the same cryptocurrency, it will completely destroy the trust in cryptocurrency, right? Because of its uniqueness, because of this giving twice, perfect. Because of this uniqueness only, we all trust in cryptocurrencies, right? So by the miners, like once we have the miners in our hands, once we achieve the consensus mechanism, we can make sure that there is no transaction that is repeated or no single crypto coin is spent twice. Everything is unique, every transaction is unique. So by achieving all the things which we discussed in the consensus mechanism will help us prevent double spending. And the last but not the least is able to handle node failures. So here node failure, as we spoke about this, node is nothing but a computer, right? And we are here, let's say there are in a blockchain around 10 are now the miners, and they all are active participants who have been selected. So let's say one node failed or one node got attacked or something happened. The other 9 nodes or other 9 active computers should be able to handle. That means the work, even the little workload, they should be able to handle in order to solve and achieve no no other information which has been repeated, and no fake information or no fake transactions. So by, like, as we were speaking about, does it have enough storage, does it have enough utility in order to achieve something, right? In order to mine a crypto coin, that's what we were thinking about. So just like that, here you can by following all the the things which we discussed in the consensus mechanism, you will be even able to handle this node failure. So the other things will be able to handle it, other nodes. Got it? So this is the main importance that the consensus mechanism brings to the table for a blockchain network which has been formed or generated, and this will also help new people to join and trust into this. So all these days we have been discussing only the basic part of it, like transparency, security and all. Now we are going into deep of how blockchain will help us. So I hope it is clear. Please let me know if it's clear or not, otherwise I will just repeat the points again. If you want me to repeat, please put it there. While we move on to the next one, please let me know. So I hope you don't have any I don't think like it's clear enough, I think, and I don't think you need a repetition. So I will be going to the next point. If so, please put it in the chat box. Do not hesitate to go back. So now, after discussing all the things, all the features of how to achieve consensus mechanism, now let's talk about the proper definition. So before it was a simple one, that is coming to an agreement, but then how is it achieved? Like we saw all the methods. So now please give an example about, may I know an example about? Please let me know, Samina, right? Please let me know what do you need an example about. Okay, I'll just take a normal example. Like let's say we have a classroom and a voting system took place in a perfect manner. So is there any chance that he or she will even show a disagreement, because everything was transparent, everything was in terms of incentive mechanism? So yeah, okay, incentive mechanism. Let's say we have a blockchain. So one blockchain might have, let's say, my main thing is to have transparency and security, and other blockchain might have security only as their main motto. So all the miners, because miners don't even know each other, the people who join in blockchain can be known people or can be the people who you don't even know. So let's say if these people will, let's say, okay, we'll take in real basic terms. Let's say we have a classroom, and our classroom's main motto is to maintain cleanliness, that not even a single dust thing or a small chocolate wrapper should be given there. So if we tell the students that if you make sure that it's all clean all the time, you will be given some incentives. Let's say maybe 1 mark or 5 marks extra for better behavior or something like that. So the thing which you give to the students is an incentive, and making sure these people are making sure because they want the incentive, so they'll make sure it is clean. So that is how it works. So these incentives, let's say in a blockchain you want to achieve security. So if all the miners are making sure that there is no third party involving, and there is no fake transaction that is taking place, and they are making sure that there is no duplication, if the miners come up with all of these, they will be getting in return something in return. Maybe you as I took an example for generating one cryptocurrency, you can just reduce their mining time. You can solve half of it and give it to them as an incentive. I hope it is clear now. So I am moving on to the next one. The next one is, what is consensus mechanism? After discussing all this, this is where your definition needs to be perfect. So the consensus mechanism is a technique to attain unified agreement. Unified agreement is everybody coming to one single agreement. I hope I can say that. And the second thing is on a state or status of a network. So everybody, are there any cryptocurrency other than, yes, there are so many cryptocurrencies, Dogecoin, Ethereum, Ether, many other cryptocurrencies. There are many cryptocurrencies. You can search for the example simply in Google, and you'll get hundreds of them, where you might have not even heard few and you might know few. So as I took examples, Bitcoin, Ethereum, Dogecoin, and many like that. So please, there are many other cryptocurrencies, and each cryptocurrency follows different mechanisms. So that's the reason we had case study about Bitcoin, where Bitcoin follows each and everything that is there for what we say in blockchain technology. Each and every point which we have in blockchain technology is being used by Bitcoin. That is why we have one big case study about that. And other coins have different things, like Ethereum uses smart contracts concept more. So that is how it goes on. I hope it is clear enough. So yeah, coming back to this point, what is consensus mechanism? It is a technique to attain unified agreement on a state in a network. So everybody coming to one single agreement is nothing but consensus mechanism, and that is what we attained seeing all of these. Next one, it ensures verification and validation of information after being added to digital public ledger, so that only authentic transactions are recorded on the blockchain. So only the safe transactions with passwords, only the transactions with the things which are verified, which are validated, which are not repeated, only they are added into a block. By what? By achieving consensus mechanism, which we discussed all over before. The last one, the consensus algorithm securely updates the blockchain data without the need of intermediaries. So now let's say I want to send some data from A to W. Now I don't have to go through A to B, B to C and till W. I can directly go from A to W, as we are all interconnected, and as what do you say, as it is all interconnected and there is no person you should be relying on. So I hope it is clear that what is conscientious mechanism. And the thing is, even for this we have challenges to face. So everything has a good thing and a bad thing, right? Just like that, there are limitations and there are positives about it. First thing, the positives is defense from DOS attacks. So denying of service attacks. So there is no, as we are making sure, even if one system is crashed, are the other able to take care? That's what we wrote. And also we saw if there is enough storage, if the computer can handle that much or not. So there is no way that the transaction will have a traffic. I mean, the transactions won't be waiting for it to be verified. It is done time to time and it's fast. So there is no way that the denying of service, like once your Bitcoin is mined, you'll get it in your hand and there won't be any waiting period because of this. And then prevent abuses and misuses. Of course, when you are making sure all these are verified, checked, they are not duplicated, is there any chance that you can misuse them? Yes or no? Yes or no? Just asking if you got the point, if you understood the gist of it. Once we go on, we'll go with the activity where you'll understand it even more better. So, okay. Anyways, coming back to this, what are the limitations? First thing is hugely expensive. So, as I told, if you want to start mining a Bitcoin or a cryptocurrency, you need a lot of energy, you need to buy a nice graphic card, you need to have a lot of storage space, etc., etc. In order to set it up, it's very much expensive for a common person to, start mining Bitcoins. So, it's a lot of energy. So, it's a lot of money into it. It's not just the value of the crypto coin you'll be getting, it's the lot of thing which you put in as the investment. And the next one is uselessness of computation. What do we mean by computation? It is nothing but solving certain set of things. So when we talk about this solving certain set of things, as we were discussing before about half-mined, you remember half-mined Bitcoins which get burnt or so. So now let's say it's only half-mined, and do you think you can use it somewhere? No. And do you think it's like something effective? No. Once it is burnt, there is no point of all the computation you did so far in order to mine at least that half the Bitcoin. So this is one big disadvantage that we are wasting a lot of computation process by doing half of it. So that is one limitation which we have here. So yeah. If you have any questions, let me know. Meanwhile, I will be discussing the activity in order to understand, and as we have 15 minutes more time, you will be coming up with many of them. Yeah. So first one, for proof of work, how to make it simple. So imagine a classroom where students need to solve a math problem to vote. If the first student to solve it gets to cast their vote, but they have to show their work to prove they solved it correctly. This ensures that everyone agrees on who gets to vote and prevents cheating. Just like you want to make a transaction. Here your vote is nothing but transaction. In order to make a transaction, you need to solve certain set of things, that is algorithms. And if you solve it first, you will be getting that Bitcoin first. You will be getting that transaction first, right? So that will prevent cheating, and whoever does it first, of course, will be getting the thing. And there is no way that other person will say even I want, right? Because he or she solved it first. So the second one, proof of stake. So in this scenario, students can earn voting power based on number of tokens they hold. So like class participation points. The more tokens they have, the more voting power they get. So a student who participates a lot in class discussions gets more voting power compared to someone who doesn't participate much. So let's say there are hundreds of meetings. I mean, every person, like every contestant will give a meeting, right? They'll say this is my thing if I'll win and all. So if a student, attends all of them, he or she will get those many number of tokens. And whoever has most number of tokens, here tokens indicate stake, whoever has most part of it, they will be getting the power to validate. Whoever can, whoever node or whoever computer can take more number of transactions, they will be getting the power to validate it. So here it's decentralized, no, it's just proving taking. It's not like one person is assigning it to somebody on the basis of trust. So this is the second example I have taken. And for delegated proof of stake, this is like electing class representative. Instead of every student voting directly, they choose a representative to vote on their behalf. These representatives are trusted classmates who are responsible for making decision for the whole class. So this one, can we relate this point to our regular voting system? Lok Sabha, Rajya Sabha elections. So we do it for the state level, and for the central level, the people we elect will be selecting it there. So isn't it similar to our Indian constitution? Isn't it similar to our regular voting system which we are doing right here? So please put up your answers. And I'm going to discuss only till authority, and I want you all to come up with an examples in the next coming 10 minutes for the rest of the one. So here I took it for proof of work, proof of stake, and delegated proof of stake. And now proof of authority. Leaving those four aside, I want you all to come up with nice examples about all the other in the coming 10 minutes. I request at least 2 to 3 answers are appreciated. So the last one, I will be reading it, and so that you'll get a hand of how to try to make these. So imagine the teacher as the authority figure, as they are the only ones allowed to vote. But they have to follow certain rules and guidelines. For example, the teacher can only vote during specific times and must justify their decision based on classroom rules. What does this mean? So the teacher has the authority. Yes. So she can take the decision accordingly. But only they are allowed to vote. And they have to follow, like, see, the teacher cannot go with her favorite part. I like this person, so I'll vote. No. They have to go by certain rules and guidelines, and if they met those priorities, things which are there in the checkbox, if all of those are met, the teacher will choose accordingly. So here the authority has been divided, and they are allowed to do it only once, where, like through the voting, and the authority is given, but they should also follow certain set of rules even if they have the authority. So these are the few examples I took. Now I request you to do it for the rest one. I'll stay here for 10 minutes. So please make sure you give me at least few examples for the rest of them. So I'm right here. I request you for your answers. Please put it in the chat box. Please put it in the chat box. As I gave you many examples, now come up with things for others. Any questions, please let me know immediately. Please put it in the chat box. And if there are no questions also, please let me know that you don't have any questions. I got only one response, no questions. Also, please come up with the activities or the examples which we can tell the students for all the other concepts, as I showed 4 of you to you. So please put up in the chat box, and also no questions also please put that also in the chat box, so that I will have a small picture that you have understood the class or so. I hope everything is clear, and also from your end, please put up a request to have a meet so that we can discuss in a better way and interactive way. No questions, but the activity part, I request you to please try from your end. Please try to, yes, interested in Google Meet, yes, please put up those messages so that I can show it, and I can work on it as well. Yeah, I want at least 4 to 5 people to react, to put up the messages so that we can ask or request them in order to have a better interactive session online. Oh, YouTube is excellent. Okay, that's fine then. That's great. Okay, so I consider no questions so far. If you're interested, please let me know. And we'll be meeting tomorrow. Have a nice day. Thank you so much. We don't need to record. We can retrieve video whenever we want. Okay. Oh, I got the point. Yes, that is a good thing. Maybe we can, put up the same meet in the YouTube live so that you can access to the class whenever you want. But okay, then if that is the case, if that is great, please try to be interactive. Please try to be more interactive, and we would be really happy for the same. Okay, so thank you so much. I will be I'll be taking a leave. Let's meet tomorrow.
Everyone. Good afternoon. I hope you are with me. Good afternoon, everyone. I hope you are there with me. Okay, so welcome back to our new session. So today we'll continue the same topic, security. We have different things to secure our data. So before that, going to our today's session, if you have any doubts, please ask in the chat. If you don't have any doubts, I'll ask few questions from yesterday's class. So with that, we'll start today's session. Do you have any doubt from yesterday's session? If you are clear with yesterday's session, so that it is easy to understand today's session. Okay, so if you don't have any questions, I have few questions for you. So first question is, yeah, my question is in the chat. Please answer that question. What is firewall? Why it is used? Any answer for the question? Safety barrier between public and private key. Good answer. Any other answers? Okay, so we use firewall to protect our data from the hackers or from the unauthorized people. So that will happen when the people are attacking to our network or to our systems. But when we are exchanging our data, the data will roam in the network. So we use firewalls to protect from the public networks or private networks when they are attacking our systems or our network. But when the data is roaming in the public network, we need protection for the data which is in the public network, right? So today's topic is that how to protect data from the public networks. So with this we'll start today's session. So there is something called encryption and decryption. Anyone know what is encryption and decryption? Please, I need answers if you know what is encryption and decryption. What is encryption and decryption? Coding and decoding, yes, true. Okay, so we'll go forward. There are some security techniques where we protect our data in the cloud. When we are protecting our data in systems, we use logs, we use security pins for the system. But when we are using the cloud, we need some techniques to protect our data. So when the data is roaming in the cloud, when the data is storing in the cloud, we use few safeties, that is encryption, authentication and identity security, safety techniques, and managing access control and backup of data. Okay, so these all things we learned past classes, like we whatever we completed the sessions. What is how to back up our data? If you back up our data, how it is helps, and how to manage the access control, which is nothing but whoever needed, whatever needed, we give the access for the data. And authentication and identity security means is the person is fair or is any attacker whom we are giving the access. These all things we do. But when it comes to encryption, that is a different format, and that is a different security we give for the data. So I just want to ask, do anyone know what is ciphertext? What is ciphertext? Yes, someone told encryption translates plain text to the ciphertext. What is ciphertext? Anyone please, what is ciphertext? the plain or normal text converted using encryption. Okay. Okay, so the text which is in the form of unreadable form, like no one can else read the form because it is in the different form, that is encrypted form. Encrypted data will be in the form of zeros and ones, and that zeros and ones will be done using the different encryption techniques. So that we will learn today. So we have two types of encryption and decryption. What are those two types? Types of encryption. What are the types of encryption? What are types of encryption? Anyone know the answer? Okay, so we have two types of encryption and decryption. Those are symmetric encryption and asymmetric encryption. Symmetric decryption and asymmetric decryption. So we'll learn how to do symmetric encryption, how to do asymmetric encryption, what is the difference between the symmetric and asymmetric encryptions. So moving forward, so this is called, which encryption is called? Okay, so symmetric and asymmetric, we have two different things. So when it comes to the symmetric encryption, we have only one key, that is shared key for encryption and decryption. Where we go for the asymmetric encryption and decryption, we have two different public keys, which is one key is used for the encryption and the private key we use for the decryption. So I hope you understand these things. So we'll go for key exchange mechanisms and hashing. So this is the asymmetric public key encryption. So how we do encryption, how the data is shared, everything I'll explain. Let's say we have a WhatsApp. So there will be a sender, which is source, and there will be a destination, which is the receiver end. So this encryption, how it works is, when the data is sharing from the source, they start sharing the plain text. But how it is shared, how is encrypted, I'll show you. So which is how. Let's say this is the data. Let's say this is the image. Image is the data. This source want to share this data with the destination through the network. This is total network. How this person will share the data to this person, we'll see today. So let's say this is a source, this is a destination. So source will tell the destination that I want to send secret information. Okay, so first source will tell the destination that I want to send some secret information. So from the destination, the source will get a confirmation that sure, please share that, I can handle it. Okay, so then the source will start sending the data from source destination, which is source address. The data starts moving from the source to the network and receives the receives the destination. So when the data is sharing to the source to the destination, there is a third party guy. This third party guy can be anything. He might be attacker, he might be other user, whatever. So when the information is going to the destination, in the middle the third party guy grab the information. So the information from the destination, source will receive that. Okay, I have a text, I have information, but someone is accessing the data. Someone is accessing the data. Please share that in better way. How can we share that information in better way? So once we this first person receives the reply from this guy, so what the first person will do, the first person will keep the data in the box. Yes. So what the person will send, is it enough if I share the data in the box? Is it enough if I share the data by covering it with some other information? But still, if the data is reached the destination, again the third party guy can access the data which is in the box. They can open it, and they can also access the data. But what the person will tell that, how can I access the data which is you shared in the box? Okay, so then from the source, the source starts sharing the key. Which key they will share? The key which is used to lock the box. Which key they will share? The key which is used to lock the box. But what happens if the key is shared openly? The key is shared openly. If the key is shared openly, this person can also get the key because it is open. Yes. For protecting the key which is used to open this box, which has a information, we use one more box to store the key. That box will be shared to the destination, and that box key will be only accessible for the destination address. So I'll tell you with a general example in the real time with the example. So let's say we have a money. When we have a money, if we are holding the money in open hands and we are walking in the streets, what will happen when we hold the money and we are walking in the streets? The third person might see the money. They try to steal the money from us. Yes or no? So if we have any other cover, any other box, if we put the money in the box and we'll walk in the street, then the third person guy will think, okay, why don't we think only the money is there? There is something else he can carry. So we don't want to take that money or take that box. But few people are there, they will think in such a way, no, they are carrying some box which is very secured. So there is something in that box. I want to steal that box. That is how the third person will steal the box. But still again, if we carry two boxes, one box we carry money, we lock that box, and that key we put it in the second box. Again, if that box which is carrying the key don't have any key, what if the third person stole two boxes? They can take the key and they can open the box. So what we will do, we will lock the box with one key which is having money, and we'll keep the key in separate box. Again we'll lock that separate key and we'll keep that key somewhere else. Somewhere else is nothing but destination end. The key which is used to open this lock is a private key, but the key which is having here, that is not accessible for everyone. If the person open the key, he need to open with his key. If he open this key, then he can open this box. Then the data is visible to this person. So that is what here happening. The data is transforming from here to here, source to destination, in the form of encryption. In the form of encryption. So there is two things. We'll encrypt the data and we'll decrypt the data. So how the encryption and decryption is happening, I will show you. Okay. So let's say this is a asymmetric encryption and decryption. So what is happening here? The sender will have a public key. The sender will have a public key. They will encrypt the data with the public key, which is converted to the ciphertext. Once the data is converted to the ciphertext, this data will not visible to anyone. In which form the ciphertext looks like? Anyone? What is the form of ciphertext? What is the form of ciphertext? Please, I need answers. How the encryption is? Let's say if you have a plain text, that will be in the text form or image form which is visible. So when the plain text is converted to the ciphertext, how? In which form the ciphertext looks? It is unreadable, but which form? Okay. So the ciphertext will be in the form of binary numbers, and that binary numbers cannot be readable. Those are machine readable form. And again, there are different layers of encryption and decryption. If we use two layers of encryption and decryption, let's say we are sending from the source to the destination, that is A and B. A and B is in the form of plain text. Once the plain text is converted to the ciphertext, so what is the A looks okay, binary 0001 and the B is 0010. So once the 0001 and 0010 is in the first layer, and the encryption of second layer will be shuffled. Okay. And the third layer will be different shuffled. So this, once the data is shuffled, it is very difficult for anyone else to decrypt the data and convert into the plain text. until and unless we have a key to decrypt the data, we are not able to convert. Okay, so we use encryption to convert into the ciphertext. The ciphertext will be in the form of binary numbers, and we use multiple layers of encryption, which is difficult to access the binary numbers. So how it looks, how it is happening, I will tell you. When the sender is sending the plain text, he will attach the public key for the sender. He will encrypt the data with the public key. So once the sender encrypt the data with public key, along with the text, he will share the key with the private key with the receiver. We will encrypt the data with public key, and we will decrypt the data with the private key, which is sent by the sender. Once the sender sends the key of public key with the receipt, which is plain text, to the destination, then he can open this ciphertext to the plain text, which is called as decryption. That decryption can be done by the private key. I hope you understand. I hope you understand. Any doubts of this asymmetric encryption and decryption? Any doubts? Okay, so this is asymmetric key. How we share this? We share the private key with the destination address. We will encrypt the text with the public key. So this private key will help us to decrypt the ciphertext to the plain text. Wherein symmetric encryption and decryption, this person will have a public key, this person also will have a private key. So what they will do, this person will send the key to sender, and helping of this private key and this public key, they will generate a shared key. So with the help of shared key, they will encrypt the data. Once they encrypt the data, it will convert into the ciphertext and it will move in the network. Along with this, they will share the shared key. So they will do this shared key with the help of this private key. They will convert the shared key into the key which is help to decrypt the ciphertext to the plain text. Whereas in asymmetric encryption and decryption, that is not the case. They are using different keys to encrypt and decrypt. Wherein symmetric, they are using the shared key, which is used for the both encryption and decryption. So there are limitations and there are few things we need to keep in mind. When we go for sharing of a large amount of data, we don't prefer symmetric encryption and symmetric decryption. We use asymmetric and encryption and decryption. When we go for small amount of data sharing, we go for the symmetric encryption and decryption. Any doubts? Clear? Till here it is clear? What is encryption? What is decryption? How to share the keys? If it is clear, I will show you a video which is used to do a encryption and decryption of symmetric and asymmetric. Is it clear? Any doubts? Do you have any doubts till here? What is the difference between symmetric and asymmetric, or how to share the keys? If everything clear, I'll go for the video. I'll show you one video. Okay, if you have no doubts, just give me 2 minutes. We'll start the video. Okay. Now I'm going to show you first encryption of symmetric and asymmetric. Then I will show you how to exchange the keys. Okay? Yeah.
Encryption is all about providing confidentiality. If you remember from the earlier lesson, confidentiality is the idea that only the intended recipient should be able to interpret the data you're trying to send. So the way that would work is, let's just say my original data is the word hello. I'm going to put that through an encryption algorithm that's going to turn that into something that is undecipherable by anybody else. Now, the data before I encrypted it is referred to as plain text. It's also sometimes referred to as clear text. Those are both two words that mean the same thing. The data after it was encrypted is referred to as ciphertext. The idea is that the sender is going to generate some plain text, encrypt it, and then send it across the wire as ciphertext. The only person that should be able to take the ciphertext and turn it back into the plain text, otherwise known as decryption, should be the intended target, the intended recipient of the message. Now, what we are looking at here is referred to as simple encryption, where all we are doing is taking plain text and transforming it into something else. But there are problems with simple encryption. Let's talk about it. Let's say I have this blue user on the left over here trying to send the word hello in a secure fashion to this orange user. Well, he can use encryption to turn it into ciphertext to send it across the wire. But let's now say the blue user wants to send the same word, hello, to this purple user. Well, it doesn't make sense for the blue user to use the same encryption algorithm they used before, because then the orange user will have insight in how to turn that back into plain text. Or the purple user will know how to turn that back into plain text. Instead, for every user the blue user wants to speak to, the blue user is going to have to develop a new transformation. This way, the users they are speaking to don't have insight into what was sent on the wire. If the blue user wants to speak to yet another person, he's going to have to create yet another algorithm to securely transform the word he is trying to send on the wire. So as you can see, simple encryption doesn't scale. Every user that I have to speak to, I have to generate a new way of transforming text into something indecipherable. Which, by the way, is very hard to do securely. It's not a trivial thing to find a way to scramble text to make it uninterpretable by anybody else on the wire. It takes cryptographers and mathematicians years to come up with proper encryption algorithms. And if all I'm doing is simple transformation, I can't just use a publicly known algorithm, because then the entire public knows the mechanism to decrypt. So instead, what the world uses is what's known as key-based encryption. Key-based encryption is going to combine a publicly vetted algorithm with a secret key. The algorithm itself is created by mathematicians and cryptographers and experts in the field. Moreover, it's vetted by each other, so they actually validate each other's work to make sure that the algorithm are secure. And then the secret key is just a random set of ones and zeros. And even though I'm using the same word to all three of these users and the exact same protocol for all three of these users, because I've generated randomly new keys for each user, on the wire, the ciphertext will look completely unique from one another. This way, the orange user has zero insight into what was encrypted and sent to the purple user, nor does the purple user have any insight into what was sent to the orange user. The cool thing about this is I can let the experts do the hard work of creating the algorithm, and it's very easy for me to randomly generate a set of ones and zeros to use as a key. This is what allows encryption to scale to the whole internet. Now, there are two ways to do key-based encryption. Those two ways are symmetric encryption and asymmetric encryption, and we'll be talking about both of those for the rest of this lesson. The main difference between these two is that symmetric encryption is going to encrypt and decrypt content using the same keys, and asymmetric encryption is going to encrypt and decrypt using different keys. So let's talk about what that means. To show you how this is going to work, we're going to use the alphabet. Now, for these examples, we're going to assume that there's only lowercase a through z. There's no uppercase characters, there's no numbers, there's no symbols. We're going to keep it simple for the explanation. Symmetric encryption uses the same key for encryption and decryption. So let's say I start with the word hello. I'm going to use a symmetric encryption algorithm in combination with a secret key. Now the algorithm I'm going to use for this example is simply moving the letters forward, and I'm going to move it that amount of times, in this case 3. Well, if I start at the H and I move forward 3 times, I'll end up at K. If I did the same for the rest of the letters in the word, I'd end up with K-H-O-O-R. To decrypt this, I would simply take my ciphertext and do the inverse of the algorithm. So if my algorithm was to move forward, my decryption algorithm is going to be to move backwards, and I'm going to use the same key. So if I move forward 3 times to encrypt, I'm going to move backwards 3 times to decrypt. And if I start at the K and I move backwards 3 times, I'll end up back at the H. And again, I could do this for the rest of the letters to decrypt the whole word. So that's a simple example of symmetric encryption. Notice, in particular, the same key was used for both encryption and decryption. Now let's talk about asymmetric encryption, and you're going to see it's a little different. With asymmetric encryption, I'm still going to use an encryption algorithm, but the keys I use for encryption and decryption are going to be different. Here, I'm going to use the encryption key of 5. Again, I'm going to start with H, and I'm going to move forward 5 times to get to M. I could do it with the rest of the letters in this word to get to MJQQT. Now, it might seem like you can just go backwards to get back to H, but in asymmetric encryption algorithms, the math features what's known as trapdoor algorithms. These are mathematical operations that can only be done in one way. You can't do them backwards. So in the case of asymmetric encryption, we can't actually go backwards. Instead, we have to go forward a different amount. To decrypt this, I'm going to have to take my ciphertext and use a different key going forward again. So starting with the M, if I go forward 21 positions, I'll end up back at the H. And I could do it again for the rest of the letters to decrypt the rest of the word. But notice I went forward to encrypt and forward again to decrypt, whereas in symmetric encryption, you can do forward and backwards. And of course, with symmetric encryption, I was able to use the same key to encrypt and decrypt, whereas with asymmetric encryption, I had to use different keys to encrypt and decrypt. Now, let's talk about those keys a little bit more. Those two keys I used, in this case 5 and 21, are mathematically related. Whatever I encrypted with 5 could only be decrypted with 21. There are other combinations of keys that you could use in our little example using just the alphabet. Actually, anything that adds up to 26 would work. So I could have also used an encryption key of 6, a decryption key of 20, or an encryption key of 10 and a decryption key of 16. But the interesting thing to note is here I used an encryption key of 5 and a decryption key of 21. Well, what if I use them in the reverse order? What if I encrypted a 21? Could I not then decrypt with 5? Well, let's give it a shot. Again, I'm going to start at the H, and I'm going to see if I can move forward 21 times. That'll bring me back to the C, and I could also do the same for the rest of the letters. And then to decrypt this, I would again take my ciphertext and then move forward another 5 times. That would bring my C back to an H, successfully decrypting the first letter of my plaintext. I could again use the same decryption key to decrypt the rest of the letters. The main thing I'm pointing out here is this property of asymmetric encryption is that what you can encrypt with one key can only be decrypted by the other key, but it works in either direction. I can encrypt with 21 and decrypt with 5, or as we showed earlier, I can encrypt with 5 and decrypt with 21. These two asymmetric keys are mathematically related. Now, what the industry does with this is they take one key and they label it as the public key, and they make it available to anybody that asks for it. And then they take the other key and they call it the private key, and they keep it to themselves. They never share their private key with anybody else. This way, anybody can use your public key to encrypt something, but only you possess the private key that allows you to decrypt it. Now, we're going to be talking about public and private keys in more detail in the next lesson. We're going to show you the different operations you can do with public and private keys. But for now, I want to continue comparing and contrasting symmetric and asymmetric encryption. Next, I want to tell you about the strengths and weaknesses of either method of key-based encryption. Now you'll notice that these strengths and weaknesses are in relation to each other. The first one we're going to talk about is that symmetric encryption is faster. It's easier for CPU to do the math and work with the keys of symmetric encryption algorithms. Whereas asymmetric encryption is slower, it is harder math and uses bigger keys. Therefore, when comparing the speed of asymmetric encryption and symmetric encryption is much faster. Moreover, symmetric encryption has this interesting property that the ciphertext that you've encrypted ends up being approximately the same size as the plain text. The benefit to that is that when you put something through an encryption algorithm, that doesn't end up doubling or tripling the amount of data you have to put on the wire. Asymmetric encryption has the unfortunate property called ciphertext expansion, where typically what you end up encrypting with asymmetric encryption ends up being larger size-wise to what you initially had as your plain text. And finally, a weakness of symmetric encryption is that since you're using the same key on both sides, that secret key must be shared. That's a problem because you have to figure out how do we get the same key on either sides of the wire in a secure way. Therefore, symmetric encryption is considered less secure than its asymmetric counterpart. With asymmetric encryption, that private key never has to be shared. You never need to send that.
And what is encryption and what is decryption? Yes. So, are you clear with this? Please tell me, are you clear with this? Encryption and decryption of symmetric and asymmetric? Yes, please answer me. If you are clear with symmetric and asymmetric keys, so now we'll go for the key exchange. If you are clear, I'll go for that. Yes, I need answers so that I can move forward. The notes, we got a intimation from the management that we can't share the notes. So if you want any doubts, you can clarify in the class, or if you have anything to go through, we have a live, right? So once the live ends also, the video will be in the YouTube, so you can check it from there. Yes, I want answers. Is it clear? Okay, so till now we know about what is asymmetric and symmetric, how the encryption and decryption is happening, right? So now I told you how to keys exchanged in the asymmetric and symmetric. So that thing I'll show you. Just give me 1 minute. Okay, now we'll see public key and private key, how it is exchanged. Now till now we learned how to encrypt and decrypt. Now how the public keys are exchanged. Okay, so we'll get a clarity on that.
In the last lesson, we talked about symmetric encryption and asymmetric encryption. We mentioned that asymmetric encryption uses two different keys to do its encryption and decryption. Well, those two keys are referred to as a key pair, and you can use that key pair to do encryption. So let me show you how that works. We're going to use Pam and Jim. They're going to use asymmetric keys to securely exchange data with one another. Now, since these two are two different people, they each have their own set of public and private keys. Pam has one set of public and private keys. She has her public key closer to Jim, available to Jim if he needs it, and she has her private key hidden, private from anybody else. Jim also has his own set of public and private keys, and like we discussed in the last lesson, what is encrypted with this public key can only be decrypted with this private key, and vice versa. So let me show you how these keys are used to do encryption. Let's say Jim has a message that he wants to send to Pam securely. Well, what he can do is use Pam's public key to encrypt that message. Now, the only key in the world that can decrypt this back to the original message is the correlating private key, which only Pam has, because again, the private key is never shared. That message can be sent across the wire safely, knowing that only Pam has the required key to decrypt the content of that message and extract the original plaintext. And this is how asymmetric keys are used to provide confidentiality. Recall that confidentiality is the idea that the data is only accessible to the intended recipient. And we can use an asymmetric key pair to ensure data confidentiality. But that's not all you can do with a set of asymmetric keys. There's actually something else you can do, which is pretty cool. Let's say Pam now has a message for Jim. Let's say for this particular message, Pam doesn't care about the confidentiality, meaning she doesn't care who can read this message. But she definitely wants to prove that it was definitely her that sent this message. What she can do is use her own private key to encrypt that message. Now, the only key in the world that can decrypt that would be her public key, which Jim has and anybody else has because it's a public key. So this can get sent across the wire, and then Jim can decrypt that message using Pam's public key. If Jim can decrypt the message successfully with Pam's public key, this actually proves two things. First, it proves that Pam must have sent that message. This gives us authentication. If Jim was able to decrypt something with public key, it proves that the only key that could have encrypted it was Pam's private key, and Pam should be the only person that has that key. Therefore, we know Pam sent that message. It also proves something else. It also proves that the message was not modified in transit. That is integrity. If someone captured the message in the middle and changed the content of the message, well, when Jim tried to decrypt it with Pam's public key, he would end up with a jarbled mess if the decryption would have worked at all. So if Jim was successfully able to decrypt a message with Pam's public key, then we know for a fact the message hasn't changed since Pam encrypted it with her private key. This process that we just discussed is what's known as message signatures. You can use an asymmetric key pair to create a signature, which provides authentication and integrity for what was signed. So, we just talked through how you can use an asymmetric key pair to provide both encryption to get confidentiality and signatures to get integrity and authentication. But in reality, it's not quite that simple. Remember, in the last lesson, we talked through a bunch of limitations that asymmetric encryption has. Namely, that it's inefficient to use asymmetric encryption for bulk data transfers, because asymmetric encryption is slower and more taxing on the CPU. Instead, if we want to actually protect bulk data, what we want to be doing is using symmetric encryption. But symmetric encryption has this problem that we have to first establish a symmetric key on either side of the wire, and we have to do it in a secure way. Well, that symmetric key is a pretty small piece of data. And recall that we can use asymmetric encryption for smaller, limited datasets. Well, why don't we use an asymmetric key pair to share a symmetric key? That is what SSL and TLS actually do. Let me show you how it works. Pam is going to randomly generate a symmetric secret key. This key is just a string of ones and zeros, and Pam will generate them randomly. Pam will then take Jim's public key and encrypt that symmetric key. The only key in the world that can decrypt this back to the original symmetric secret key is Jim's private key, which only Jim has, which means Pam is safe to send that across the wire. Jim will then take his private key to decrypt the content of that message to extract the original symmetric secret key, and now both parties have established a symmetric key that is identical in a secure way. They can use that symmetric key to protect bulk data. Here, Pam has a message for Jim. Pam will encrypt that message with her symmetric key. The only key in the world that can decrypt that message is the same symmetric key that was used to encrypt it. That message can be sent across the wire, and then Jim can use his copy of the symmetric key to decrypt that message and extract the original content. This can be done in either direction for an arbitrary amount of data. Here, Jim is sending something to Pam securely using that same symmetric key. Now that both parties have the identical symmetric key on either side, they can continue to use that for however much data that they want to protect. This concept that we just discussed is referred to as hybrid encryption. Hybrid encryption is the idea of using both asymmetric encryption and symmetric encryption. Now you're using both of those at different points, so it's not like you're both symmetrically and asymmetrically encrypting the same content. You're using asymmetric encryption to facilitate a key exchange, and then with this key, you are then using symmetric encryption to protect bulk data. Do you remember those strengths and weaknesses of symmetric and asymmetric encryption we talked about in the last lesson? Using hybrid encryption in this way gets you the best of both worlds. You get the strength of asymmetric encryption that you have used the more secure way of sharing a key, and the efficiency of symmetric encryption to protect your bulk data transfer. This method is what every secure communication protocol uses. This is how SSL and TLS protect bulk data transfers. This is also how IPsec and SSH protect bulk data transfer. So that is the concept of hybrid encryption. But what about signatures? We talked about earlier how you can use signatures to attain integrity and authentication on a message by encrypting something with your own private key. But again, asymmetric encryption has limitations. You can't simply encrypt an entire message with a private key. Instead, what we'd like to do is simply encrypt a smaller, fixed representational sample of that message. If only we had a way of converting messages to smaller representational sizes. Well, we do. We talked about hashing algorithms earlier on in this course. We define them as a thing that specifically exists to take a message of any size and produce a smaller, fixed width fingerprint of the original message. And signing is going to use hashing algorithms to simplify the process. Let me show you how that's going to work. Here is how asymmetric keys are used for generating signatures. Pam is going to generate a message. She's then going to run that message through a hashing algorithm. That's going to result in a particular digest. That digest is then going to be encrypted with Pam's private key. The result of that, which is the encrypted digest, is the signature. That is actually the signature of that message. That gets appended to the message, and then both the message and the signature get sent across the wire. Now that signature was created with Pam's private key, which means on the other side, Jim is going to use Pam's public key to verify the signature. What he's going to do is take the signature and decrypt it using Pam's public key. That's going to result in the digest that Pam created. Then Jim is going to independently calculate a hash of that message. And if the digest that Jim got in his calculation matches the digest that Pam had sent, this proves two things. First, it proves that the message has not changed since Pam signed it. Remember, this digest was created by taking a hash of this message. So if anything changed in this message, Jim would have gotten a different digest. This gives us the property of integrity. The other thing that signatures prove is that only Pam could have created the signatures. This signature was created as a result of taking Pam's private key and encrypting this digest. Well, if Jim was able to decrypt something with Pam's public key, this proves it was definitely Pam's private key that signed it. And the only person in the world that has Pam's private key is Pam. This gives us authentication. So using an asymmetric key pair to generate signatures in this way gives us both integrity and authentication for the content that was signed. Now, we've been discussing this from the perspective of a message sent across the wire. But keep in mind, many different things can be signed. Sure, you can sign messages, but that's actually pretty rare. Often, what you see signed is much smaller pieces of data, things like a single certificate, or things like a single piece of software, or an email, or whatever the case. So this definition of signatures should not be limited to just messages. You can sign anything. And that wraps up our discussion of public and private keys. The main takeaway from this lesson is understanding hybrid encryption and how we can use asymmetric encryption to securely establish symmetric keys, and then we can use the symmetric encryption to protect bulk data at scale. And the other thing to understand is message signatures, how they are a function of using your own private key and a hashing algorithm to prove you signed something and it hasn't changed since you signed it. In the next lesson, we're going to summarize a lot of what we've discussed so far in this module. We're going to tie it all together and show you how SSL
Let's come back. So till now we have seen some videos of encryption, decryption, yes, and also how to exchange the key. So yeah, any doubts from these two topics? Types of encryption, yes, how to encrypt the data, how to decrypt the data, what is key, how we exchange the keys to encrypt and decrypt the data. In the video we have seen one example of encryption and decryption with the key, right? We use one key, okay, which related with in the alphabets. We use the same key to retrieve back the same whatever the information sent by the source. I think you are clear with these two topics, encryption and decryption. Okay. So any doubts you have, please ask the doubts. So we have more 20 to 25 minutes. So I'll wait for some time. So if you have any doubts, please. Any doubts, not only related to these topics, any previous topics or any doubts, please. Yes, I'm waiting for you. Any doubts you can ask. No one have doubts? Okay, if no one has doubts, so I'll tell what we are going to discuss tomorrow. So I'll tell you hashing, how to do hashing, okay, with the practical. Tomorrow is a practical session, please be attentive. So tomorrow we'll do how to do hashing, and we also do some practical sessions on how the encryption and decryption is happening with the keys. We use one key to encrypt, we use same key to encrypt. In some cases we use the one key to encrypt and one key to decrypt. So we'll go for the practical session tomorrow. I hope you clear for today's session. Any doubts you have, let me clarify. If you ask the doubts, I can clarify. So tomorrow's session is going to be on hashing and encryption decryption practicals. No doubts? Okay, if you don't have any doubts, we can wind up the session. So I'll wait for more 1 to 2 minutes. If you don't have any doubts, so I'll wind up the session. Okay guys, thank you everyone. I hope everything is clear. So with the new topic, encryption and hashing and encryption practicals, we'll meet tomorrow. See you. Thank you.